tonight I'm going to give a little presentation on the hardware. These hardware kits are Arduino based. There's basically 4 pieces of hardware involved in this little demonstration I'm going to give you. As far as the code development goes, they all work with the Arduino IDE. And I purchased, let me know if, is my screen still on? I'll try and show you a little up close picture of the, can you see that?
It's blending in with the background a little bit.
Yeah, you need to turn that goofy background stuff off.
Okay. You know what? Let me defer this because I actually have another slide that's got a picture of the hardware that I'm going to talk about tonight. So these kits are amazingly cheap. For about 13 bucks, you get the Arduino board, the OLED, and then you get it's the BME 280 sensor that measures temperature, humidity, and pressure. And then for a few bucks more, you can get a motion sensor. So let's kind of go forward with the agenda of what I'm going to talk about. So we have the hardware being used is the Wemos Mini D1 development board. We have a nice OLED display. There's a temperature, humidity sensor, and motion sensor that I talked about. After the hardware introductions, then I'll go into some Arduino IDE examples. We'll do 2 of them. We'll actually do over-the-air programming of the mini development board using Wi-Fi, and then we'll actually run some code which will read the sensor data and display it to the OLED as well as a web page. And then beyond that, we'll introduce MQTT, the concepts of MQTT and configuring it on a Raspberry Pi as a server, and then the client program for MQTT will be the Wemos development board. Going forward, I'm going to use the term IoT board to basically mean the Wemos Mini and the associated sensors. It's just a lot easier, and it saves a little time. So let me switch applications here to show you what the device looks like. I'm going to take this to full screen. Okay. How is that? Is everyone able to see that a little better?
I see a PowerPoint.
Oh, is the
or
okay.
the slideshow?
Yeah, you know what? Okay, so let me switch. I know what the issue is. I have to change applications that I'm sharing. Now, let me see if I can. Let me see if I can figure out how to do that in Zoom. Okay.
If nothing else, you could stop sharing and reshare the other window.
Okay. Yeah, that's a good idea. Thank you. Let me try that again. I'm going to share screen, and then, this will do the trick. Thank you. Okay, so hopefully this is a little better. I'm going to go to full screen. How's that?
Yep, I see it.
Okay.
Good breadboard.
So can you see my pointer here? I'm moving the mouse.
Yes.
Yeah.
Perfect. Okay. So what we have going from left to right is the Wemos development board. To the left here, it has a micro USB interface for powering the board for 5 volts, as well as a serial connection for download from the IDE. Here you can see the Wi-Fi antenna. This device is a 2.4 gigahertz radio, so it supports the BG&N wireless standards. Here we have an OLED display. This is really a nice display. I'm amazed at how bright it is, even in bright lighting conditions. It's got a fairly generous viewing angle. It's quite readable. Over to the right here, this is the BME 280, and this is a pressure, temperature, and humidity sensor. We're all these connections for data. I'm using the I2C interface, and it's wired accordingly. This device here kind of looks like half a golf ball, but that's the motion sensor. And if you look closely, there's two potentiometers here. And so the first potentiometer adjusts, is basically like a hold time. So if you detect motion, it will send a TTL logic signal. So this potentiometer defines how long you'll hold that signal before it resets, provided that no motion has been detected. The other one is and that ranges, I have it later in the slide, I'll discuss that. And then here we have a sensitivity adjustment, which defines how far away from the motion sensor it's able to detect any motion. And again, it's kind of a narrow range of distance. So that's the hardware we're going to be talking about. I'm going to stop share and let me switch back to my PowerPoint. Okay, so just some brief points about this Wemos Mini D1 board. It's based off of this 8266 chip. As I mentioned earlier, it supports the Wi-Fi BG&N standards, 11 digital pins configured for I/O, analog input, which actually the motion sensor uses that analog input to report motion detection. We have an 80 megahertz clock speed. And as I mentioned earlier, I'm using the I2C serial protocol. However, it does support SPI as well. Just a couple of quick things about the OLED. The addresses, the I2C address is configurable in case you have other I2C devices and to avoid conflict. Voltage range is 3.3 to 5 volts, which we have no problems providing with our USB supplied power. And then 128 by 64 white OLED pixels. Each pixel can be turned on or off with the microcontroller. A little bit about the temperature and humidity sensor. Supply voltage range 1.8 to 5. Again, supports both serial interfaces. Fairly generous operating ranges. You could certainly use this for if you wanted to build a weather station. Most of the temperature and sensor ranges are well within what you would see. Unless you were in Siberia in the wintertime, then you're probably going to go below -40 C. A little bit about the motion sensor. It's kind of on the low end of what I can supply for voltage from USB. 5 volts is the minimum. There's your 3.3 TTL signal, which goes to the analog input. A little bit about the potentiometers that I mentioned earlier. The hold time or delay time, you can set anywhere from 5 to 300 seconds. When I demo this a little later, it's set for around between 20 and 25 seconds before it resets itself, provided no motion's been detected. These potentiometers, they're pretty sensitive. I was amazed at how slight of a turn it takes. You get a big jump in delay time values. And then the motion sensor sensitivity, 3 to 7 meters is kind of the limits that this thing will detect motion from. Okay, so let's move on to the second part of the presentation. That's involving just doing some simple applications using Arduino. The first one I'm going to do is over-the-air programming. One thing I'd like to mention to you, and I haven't pursued this, to program something over the air, one of the things you might want to be concerned about is security. You don't want anyone coming by and just pushing code into your IoT. So there are some protocols that you can set up. I did not do it for this example, but that is something that is available if you want to dig into the Arduino library for this. So the first example it's a fairly trivial one, but it'll kind of illustrate that the over-the-air programming does work. So what I'm going to do is I have it set up here. So right now, can you see a flashing LED and can't see the board?
Yep, I see it.
Okay, so this is flashing at roughly 1 second on off. So I'm going to have to, let me do a little switch of the applications. So now what I'm going to do is I'm going to go to the Arduino IDE and go ahead and share that. Okay, and then I'm just going to blow that up to full screen. Okay, so what I'm going to do here.
Are you running the IDE on Linux?
Actually, this is on a Mac. I have installed the IDE on a Pi, but I haven't really played around with it too much.
I run the IDE on a Linux Mint in my lab. Have been for years.
Okay, so has that been working out pretty well for you?
Yeah.
Okay. So this, okay, so we can all see the Arduino IDE. So what I'm going to do, I'm going to show you a couple things. And so you can select a port. So right now, you see that I'm going through the serial port. So what I'm going to do now is I'm going to do a couple things here. One, let's change it to 500 just to really show the visually, yeah, it really took the code. So what I'm going to do is I'm going to go ahead and just kind of recompile it. So how fast is your Arduino? This seems pretty slow to me. I mean, these aren't big programs. Okay. So we're done compiling. So before I flash the device, I'm going to go up to Tools, Port, and I'm going to select this IP address, which is over the Wi-Fi. I'm going to select that. And then I'm going to recompile it. Okay, can you see the blinking light?
Sometimes.
Yeah, the background is still interfering a little bit.
Oh, no, I see it.
Okay. Uh-oh.
Yeah.
I have a little problem here. So I think there might be something with the IP address may have changed on me. So yeah, let me try this once more. Part of this is I kind of done this to myself. I should have made the IP address on this device pseudo-static based on the MAC address. So it's kind of hopping around on me. Oh, I know the problem. So I got to do something here. So I'm gonna plug this into a USB power supply.
It just looks like that big fish. It's part of the board.
What's that?
It just looks like that big fish behind you just eats part of the board.
Oh, okay. Yeah, hold on a sec. So let's give this another try. I can actually see the screen now. So tools. Okay, let's try this again. Yeah, the problem is I have a my USB cable is pretty short, so okay, I'm having a little problems with this. Now let's see here. So this one thing that it's good to mention now. This mini development board actually has a little reset pin on it. So I'm just going to reset it.
Do you have
And
something like Bonjour loaded on your Mac where you can scan for the IP address?
I don't know. I don't think I have. I haven't used Bonjour. I've heard of it, but let me try one other thing here that might work. Let's see here. Yeah, I'm going to have to, I may have to defer this example, but it worked before. I'm going to, let's see if, actually I'm going to try something here and go,
I hope you can hear me here. My microphone isn't the best, but when I was experimenting with this as well, you notice you've got that Arduino OTA things like that. I don't know if that is the piece of code that you need in there, but there's a block of code that has to be included every time you push the program, because otherwise it won't be listening for on the air.
okay.
I only mention it because it's commented out, but that might not be the magic code. That was the first mistake that I made when I was doing it, and it flashed and it was great and it did it great. And then I wanted to update it again, but I found out that I didn't put the other stuff in there.
Okay. Yeah, like I said, I did this demo just before the presentation. So we have a couple options. I can move on, or if you want to give me a few more minutes, I just need to resolve get the IP address and point to it. Let me go to, I want to go to serial monitor. Oops.
Or you can describe what we want to see.
Okay. Well, again, basically the intent was to change the flash rate of the LED on this board Yeah, I see what you're saying with the background. So that thing should be flashing at a faster rate once I do the over-the-air programming, because I basically change it from 1 second to 500 milliseconds. And that was basically what I was trying to get out of this demo. We can go ahead and I'm going to try one other thing real quickly. Okay, there we go. So can you see my screen? I have a serial monitor. So it booted and tells me my IP address is 118. So now let me go back, and now that I know what the IP address is, let's see if we can take a second crack at this. Okay, so now I'm physically disconnected to the serial communication. So 118 was the one I said, right? Okay.
You did.
So let me just recompile it. It's, like I said, this IDE is just really slow. Yeah, it just finished compiling. So let me revisit just to make sure that my port is set to 118, and it is. So now let's go ahead and do an upload. I'm going to kind of tilt my screen here. It's compiling. Okay. Yeah, see, I'm not getting an answer here, which is a little disturbing. Why don't we go on? Like I said, I don't want to, unless you guys don't mind me just doing a few more quick troubleshooting attempts.
Rob, do you
Ryan,
want to go on and maybe come back to it at the end?
yeah, we can certainly do that. Okay. So let me go back and I'm going to stop sharing. We'll go back to my PowerPoint. Back to slideshow. Okay, so yeah, we'll go through that. The next one we'll do is reading environmental and motion data. So I'm going to break away from this PowerPoint, and we'll pull back Arduino IDE because we're going to need to build off of that. Let's see, there we go. Okay, so what I'm going to do is open recent project here. Okay. I'm going to close this one. So let's go ahead and verify this build, this project. One more to look at. Can you see the Arduino screen?
I see the IDE.
Yeah, okay, good. Wow, this is just really, really slow. I wonder if Zoom is killing my compile speeds, because before I got on board with the meeting, it was definitely running a lot quicker. Can you imagine if these are really big programs? Okay, so now let's go back to the port. Let's go back to our serial port. And now I'm going to flash the device.
Yeah, we can't see the serial port, although that's fine. But there's that device that's it's a serial terminal that's communicating with the chip, right? So that you can see that just off screen right now.
Yeah, you know what? I'm going to, let's see. I should probably turn off my background. But okay, so right now it's writing and it just did a reset. There, you can kind of see the OLED's active now.
Hmm.
Okay, so I don't know how well this would work. I was going to try and.
Now let me decoy that shark.
Yeah. Okay,
Yeah, that's a nice shark.
Yeah, it's certainly biting me in the end here. Okay, so basically in the OLED, I'll tell you, I'm seeing temperature, humidity, pressure, and then I'm basically seeing any triggers of the motion detector. So let's go to, I'm going to stop sharing this screen, and then what we'll do is we'll pull up a web browser, and because this stuff is being sent to, yeah, maybe I ought to share my Firefox. Okay, can you see you see my browser now? There's a page, environmental display.
Not seeing it.
Okay, let me go back and how's that?
I see it, yep.
Okay, so the nice thing about this program is when if I hit the reset pin, it shows me network diagnostics that it's connecting the SID, and 164 is the IP address. So I'm going to type in that. Okay, let me refresh it, because if you look at the date on here, it's basically the beginning of the Linux epoch. And the code here does connect to a time server. Let's see if I can. There we go. Okay, so now if you look at the time here, it's definitely correct. So here's our temperature. I'm upstairs, heat rises. I don't have the air on, so it's kind of toasty in here, 89. There's your humidity, and then the pressure reading. So I'm going to demonstrate. It's a little bit hard because you can't see the hardware, but so if you look down here at raw data, this is when the motion sensor triggers. So right now, I'm going to wave my hand over the sensor. And then, okay, so there's the first one at 7:05 p.m. That was the first trigger of the motion sensor. So right now it's 13 seconds since the event. So again, this is on the OLED, and I expect you to see it. Okay, so now after about 20 seconds, it, you see now because I moved my hand to click the mouse, it re-triggered. So you'll see a second one about 30 seconds later. And just a couple things, it keeps track of the counts of number of motion events detected. This is a daily thing, so it'll clear at the end of the day. Here's your start delta. I said it's about, or the elapsed. That's that potentiometer on there. It's set for around 21, 23 seconds. Okay, so this is really the second application I wanted to demonstrate to you. now I'd like to move on. Let me go back to, are there any questions right now before I proceed with the next topic? Nope.
So that this web page you're showing us, that's actually being hosted by the ESP device?
So it's actually, I can show you real quickly in the Arduino, but basically there's code in there that will generate this page. Let me go to the Arduino IDE and show you where that lives. So this is where it's basically being generated. Right here, this, hold on a sec. I'll make sure I got the, okay, send HTML page. So this is the HTML being produced.
Yeah, and being an 8266, there's also some flash memory that could be devoted for general purpose file storage. So you could actually even create other web pages with CSS files and graphics and things like that, and write something in Angular or React or whatever like that.
Okay.
But this is what I usually do with the brute force method there.
Now, one thing that I didn't do in this demo, but this line here, I commented out, but when I was showing you the web page, I was periodically hitting the refresh button. So if I activate this line here highlighted, then it'll do an auto refresh every, in this case, 5 seconds. That's probably not a bad thing to do when you're monitoring the data. But yeah, this is the code that's being generated for the page. Okay, so let me go back to the presentation here. Okay, so now I've introduced MQTT. It's a server-client arrangement. So here's the motivation, and when you start thinking about, you know, the inexpensiveness of these boards and what you can do, this is a perfect opportunity for home automation. You can put one of these in each room or, you know, your business, kind of distribute them about. So you got all this sensor data floating around over your network. Why not have it being read to a centralized location? So MQTT, I think, in my opinion, really fits the bill because it's low bandwidth. It's fairly easy to set up. So let's talk a little bit about MQTT. So MQTT, what is it? It's message queuing telemetry transport, and because it uses TCP, it has guaranteed delivery to the server side. It's an open standard. There's a lot more to MQT, as you imagine, than what I'm showing here tonight. I just kind of wanted to introduce some of the basic concepts. You know, for example, in the client, which is the IoT, is responsible for publishing data, but it could also subscribe to data. And I'll kind of talk about those terms in the next slide. When I was on a bike ride, I had nothing to think about, and I'm kind of amazed at all the Bluetooth stuff running on my bicycle. I said, well, gee, can I have MQT on my bike using Bluetooth? And, well, there's a variant of it which will work with the Bluetooth if so inclined to do something like that. I just need an IoT board that would work with Bluetooth. Ports 1883 is unencrypted, and then 8883 is encrypted. Everything I've done tonight and in the code is using 1883 as a port. Okay, so what we do in MQTT is we organize information in terms of topics. So the IoT board, in my case, will publish a topic to a server, and I'll show you exactly how these are named in the code. From the server side, if you subscribe to a topic, then you can basically see any data that's been associated with that topic. And again, what I said earlier, these are very basic concepts. There's much more to it. And have at it with internet searches for MQTT and find out a little bit more about it. Okay, so on the MQTT server side, I'm doing this on a Raspberry Pi. What you're seeing here are the commands needed to install. It's called Mosquito, is what we use for MQTT on the Raspberry Pi. So I'm installing basically three pieces here: the base Mosquito, the clients, and then a development environment. Okay, so on the IoT side of the piece here, defined a couple of key things here. It needs to know what IP address to talk to that's running MQTT. In this case, it's the Pi. I've decided to name the topic as BME 280 motion/raw data. And then the next line here is actually the format which the data will be published. You'll see that when I actually show you what's coming across to the Raspberry Pi from the client side, data-wise. Okay, so one of the things I found out about the Arduino, again, I'm fairly new to this stuff, is that just the devil is getting all the right libraries for this stuff to work. And so one of the libraries from the IDE that you pull in handles MQTT. And the next line here is basically, you know, this is kind of core in terms of getting this to work. So we have a client.publish object, and then with that we associate a topic name, which we defined earlier, and then the MQTT buffer, which is how the data is going to look when it's being read from when it's being published. So at this point, I'd like to spend some time just kind of showing you what the MQTT looks like on the Raspberry Pi. So let me I'm going to switch over here, and let me see if I can share the VNC. Okay, so hopefully you can see my Raspberry Pi here. I actually have an old page here. I think there was another one here. Okay, I actually want to, hold on a minute. Minimize this. So what I'm going to do is a little demo here. So even before I attempt to subscribe, that's the term used, before I even attempt to subscribe to data being generated by the IoT client, I'd like to just do a sanity check to make sure that Mosquito is working as expected on the Raspberry Pi. So what we can do here is I've created a topic called sensor temperature, okay? So this is the command, mosquito_sub, option H, localhost, and then T, the topic, that's the name of it. So I'm gonna hit return, and it's just gonna sit there waiting for something to be published. So on this window here, I'm kind of wiggling around, I'm gonna I'm going to publish something. Okay, see on the original terminal window, you got minus 25. So that's telling me that when I do publish something, the subscriber is actually able to see the data. I can just, I can change it to 212. There you go, to minus 212. So that tells me as a sanity check that Mosquito's working. So now what we can do is we can actually subscribe to what's coming from the client, the IoT. So I've kind of set everything up here so it kind of runs smoothly, but it's basically the same command. The difference is you're actually now subscribing to raw data coming from the client. And if you look at the end of the command line, you'll see 8A3B. So basically what I'm doing there is I'm taking the last 2 bytes of the MAC address and assigning it to that name. Just so in the future, if I decide to add another IoT board, of course, it's going to have a unique MAC address. So that way it'll keep all the topics having a unique name. So if I hit return on here, okay, so the refresh rate for the data for ENVs, the environmental, is 1 minute. We're looking at, this is the Linux Unix time. Temperature's gone up. 91, 33% humidity, 29.287 inches of mercury. So, like I said, okay, there you go. And then you can see that there's basically a 60-minute time. Well, wait, we haven't gotten the second one for environmental. The motion one is going a little spastic because I'm kind of presenting here, and so it kind of triggers as needed. Let's give it a second here for the next environment to show up. Okay, so first one was 93, 153, so that's 60 seconds. That's your 1 minute rate. And so that's kind of in a nutshell how the MQTT stuff works. Like I said, it's a fairly simple concept, but now that you got the data in a centralized location, then you can go crazy with it. You can have other devices monitoring it. If you get to a certain temperature, you can have a device take a certain action. I wrote a little Perl script here, which basically makes it a little bit more friendly to read. I think they have so this was some data that I collected earlier. I just made the time human readable. So there's a lot of things here. I will, at this point, this is pretty much all I had to present. I'd like to try to make amends with the over-the-air stuff, but maybe this is a good time to kind of break from that and take questions, or let me know how you'd like to proceed.
So do you have a schematic or block diagram of your breadboard in your slide somewhere?
No, I basically have that one picture that I showed. Let me go ahead and pull that one up.
And okay. And it seems like you're using the Arduino IDE, but there isn't actually an Arduino in here.
Well,
it's an ESP chip?
Yeah, it's ESP8266.
So there's nothing hiding under the OLED display. That's just the display.
It's just a display, correct. And again, everything in terms of serial communication is I2C. Motion sensor is using the analog input on the 8266 for sensing motion.
And where's a good source for these parts?
So I picked this up from Amazon. So the three pieces that you're looking here, minus the motion sensor, I got for like $13-14.
Including the display?
It was
Yeah.
it was sold as a kit, you said? The
Yeah, it's a
three
kit.
pieces? Yeah.
Yep.
Yeah.
Like I said, these things are they're dirt cheap. They're, once you get some of the IDE stuff, the code libraries straightened out, I mean, you can do some pretty interesting stuff here. And my plan going forward is I'll buy more of these kits and put them in different places in the house. A friend of mine has the same 8266 board, and he's using it to monitor his sump pump in his basement. So what he's doing is he has basically a USB power supply hooked up to the switching part of his pump. So when that thing kicks in, it's a 5-volt signal, and he has to do a little voltage dividing because, like I said earlier, this chip will only handle about 3.2, 3.3 as a max input. But he's basically monitoring that 5 volt, and then getting data from it, and then processing the intervals, how long it's been running, time between runs, and all sorts of data. It's the only problem with the USB power supply is if you use a switching power supply, those things have when they turn off, there's a fairly long decay time on those things that probably need to consider.
I was going to mention, I mentioned this to Ryan before, I don't know, it was probably last fall. I did a presentation similar to what you were doing there, Rob, about these devices. And what we did was we ended up offering take-home kits. So we did a bulk buy direct from Wemos. So what's long and short of that is that we were able to save a few dollars each from each of the modules than ordering them from Amazon. So if you go on Amazon, or if you go on if you search Wemos D1, you'll see there's a whole bunch of modules that are available, like what you're just seeing here. And these chips stack, so you can actually stack another module on top of the board, and actually have another type of thing. So if anyone has a hankering to play around with those, some of those things are really cheap. Like there's an LED ring that has like 7 or 8 addressable LEDs on, and I think it was like $2 if you ordered them in bulk. So I have a few of those left if everybody wants to play around with it instead of having to order that from Amazon or ordering it from China. But they're great. They're really nice devices.
Well, I'm just amazed at when I bought this kit, I kind of got suckered into it. But, the cost of the breadboards, and they have these little electronic kits with hundreds of pieces in it for like $15. You got your 2N22 switching transistors, your LEDs, and, the resistors. And it's amazing. And I definitely want to play around with this some more. The other thing, too, that I wouldn't mind getting into is stepper motor control, which they do have kits for that, but that wasn't part of anything that I ordered. But it's amazing what's out there.
I have a question. How good is documentation for these modules, and how long did it take you to understand what needs to be done, like how to program this?
Well, again, the devil in the details was really pulling in all these libraries. That's probably the biggest time sink. It's always been my experience, always the software.
But literally for this kind of project, how long did it take? Hours or days?
So this one took a few days to pull in the libraries, write and debug the code. It's kind of, like most pieces of software, it's grown from something simple. It's like, oh, we can do this. Oh, well, I want to do this. So it kind of snowballs. So all told, it was probably several days. And again, I'm fairly new to the Arduino devices and the IDE. So this particular project I work on, a friend of mine who kind of helped me out with it because he had been doing a lot of stuff with IoT boards and a sump pump project. Pretty interesting. So he was certainly of help getting going too.
Yeah, another module I can recommend is it's their battery module.
Okay.
So it piggybacks with that, and basically it has the USB connector like you have in here too, but it also has one of those JST connectors where you can put a lithium poly, little square batteries on there. And so what I do is I when I need to squirrel something away somewhere that I'm not going to get to for a while, I have it powered by battery. And then you can read the battery voltage and then send it back to you. And then if it needs a little bit of a charge after a few months, I can put it in. That's been a very useful word for me for portable devices.
So is this basically like a battery backup? If you lose power, it's still.
Yeah, it's a battery backup, but it's all of these modules, they have the same form factor as the D1, and so the electronics on that board are the USB socket and then a lithium polymer LiPo charger and over voltage protection and things like that. So basically, once the battery's charged, you plug the battery into that, and it's running the device. But if you plugged in the USB, then the USB is powering the device and charging your battery.
Now,
and that is cheap.
the other thing, too, that's a good point. A friend who kind of got me into these boards, so he has a place in Florida, and he wants to remotely monitor the conditions in 3 rooms, and he basically bought a USB backup supply, not a USB, just for the event of power outages. But in terms of, I haven't done this before, and I certainly can. I have a USB charge monitor. I should just plug it in just to see how much current this device draws. I imagine it's the Wi-Fi that's probably eating up the most current.
Yeah, and depending on your application and how critical it is, most of the time you can just put those boards to deep sleep, and then they'll wake up periodically, or they'll wake up if an event occurs, and that really drives down the current capacity. You can run these things for months, depending on what you need to do.
Well, the other thing too, and I haven't looked into this, but can you actually control the transmit power of the Wi-Fi? I got to believe that somewhere there's a register for that setting.
Probably so. I've never done it, but you do have access to those registers, yeah.
Okay.
So it's my understanding that these ESP modules, out of the box, they come with an operating system on the chip and a network stack and a web stack and a Wi-Fi stack. So basically what you're doing with the Arduino IDE is you're creating one program and downloading it and giving it one program to run. But there's a whole bunch of other things going on that chip. I don't think you have to tell it to load a web server. I think it's pretty much built into it. Same thing with the Wi-Fi. The Wi-Fi is just there. You don't have to program it, or you don't have to include a Wi-Fi module, right?
Yeah, the Wi-Fi is built. It's built in.
Yeah. So there's actually, it's my understanding, there's actually like a micro Linux-like thing running on that thing as soon as you power it up. And it'll just sit there and wait to receive a program from like either over the serial or over the Wi-Fi from anything that can generate the program and send it in the right format. They just choose to use the Arduino IDE because it's everybody in the space probably has those. But there's actually, it doesn't appear to be any Arduino hardware in this solution at all. So I'm just using the Arduino IDE to do the coding and stuff of a one specific task that you're going to download.
Now the other thing too is with the with this chip is there's a watchdog you need to be mindful of, and if your tasks take too long, then you may have a reset because you didn't reset the watchdog fast enough.
Yeah, there is a small runtime that gets loaded with the Arduino programs, so it is self-contained in there. That's all hidden from us when you are including the Wemos board, the 8266 board. But what happens is part of that code that's pushed down into the chip is the necessary runtime for that. But as you said, Ron, they have other options. There's like a Lua interpreter version, MicroPython, and a whole bunch of other things like that. So you just kind of mix and match what you need. In those Java, in the Arduino programs, if you're going to need to use the Wi-Fi server, you just include the header file, and it takes care of that for you. It makes it really easy to play. It's about the easiest SSL connection you'll ever make.
Yeah, so there must be an SSL server at boot time, or an SSH server at boot time. So there's a lot of stuff in there already.
Yeah, and again, it's just including all the correct libraries to support this stuff. But it's there. So, since I'm the only one presenting tonight, normally this would have been a lightning talk, but it turned into a slow-moving thunderstorm. That I don't know, Ryan, do you want to just, while you guys, if you want to talk about other things, I can go ahead and see if I can fiddle around with the over-the-air programming, or it's 7:30 now, so.
Sure, I actually had a question for you.
Oh, sure, go ahead.
So I've been pretty intimidated by these Arduino kits because I know nothing about hardware. Well, the extent I know about hardware is I built a PC like 20 years ago, and I haven't done that much since then. Like, I see an array of pins, like places on that breadboard. Like, how do you know where to plug stuff in? Like, I would just be lost.
So all the stuff is, the boards, well, I take that back because this picture of the motion sensor, you see there's 3 wires coming in. Normally these, the board PCB are pretty good. They have everything labeled with signal names. The motion sensor, for some reason, when they screened the boards, they didn't put signal labels on. So, it's pretty much, most of these, there's basically 2 connections you're going to make. A connection for data, and then your power supply. And data connection serial, so you're going to have a clock, and you're going to actually have the actual data. And then for power, you have your VCC and then your ground. So, like if you look at the OLED there's, basically 4 wires, and I just kind of defined them.
Yep.
So generally, and as you guys want to chime in, these are pretty easy to wire up. There's not a lot of connections.
Yeah, I mean, I2C is a bus, right? So the ESP becomes the master, I believe, and all the other devices are slaves. So you got to know a little bit about that, but it's just basically your daisy chaining wires. As far as how do you know what pin does what, I mean, it's hard to see on that picture, but on the ESP, it looks like they've got a bunch of GPIO pins that are just labeled. And for a lot of things you do, it doesn't really matter what pin you hook your device to, unless it needs a specific type of interface. If it's just an LED or something, it doesn't matter what pin you hook it to. You just have to make note of that. So when you go create your program, you say, okay, this LED is on this pin.
Right.
So there's a
Okay,
lot.
so you essentially you have an address based on the row and column.
Yeah, I mean, most of these devices, all the pins that come out that aren't power or clock or reset are just general purpose I/O pins. They're not. It's not like you have to figure out how to add a memory chip or multiplexers to do all this stuff. They just, I mean, all the stuff, all the guts is inside the chip, and you're just really only presented with I/O. So in the case of I2C, there's another serial bus protocol. Can't think of the name of it right now.
Serial peripheral interface. SPI.
SPI, yeah. So SPI, like on Arduino chip, on Arduino boards, there's a recommended pin to use for, or set of pins to use for that. But I've seen notes where you can run SPI on any generic set of pins. It may not run as fast, and you have to tweak the library a little bit, but generally, if you're using one of those goofy serial protocols, you want to use the pins that the chip has dedicated to those services. But other than that, there's not a whole lot of anything else you got to worry about.
Yeah, and along those lines, Ryan, the Arduino is good to get started with. In what you'll find
So
is
easy.
when programming in it, let's say you hook up an LED to GPIO1, there's going to be a pound define. It's going to be C code. And there's going to be a pound define. And you're going to write GPIO 0 or you're going to write GPIO 1. When you write a 0, it's going to turn the LED off. When you write a 1, it's going to turn the LED on. So it's kind of fun. And there'll be a pound define so that you know I'm going to write to this GPIO pin and I'm going to write it high or low. And then something's going to happen when I write high or low.
Yeah, and if you get an Arduino learning kit that has an actual Arduino, like an Uno or any one of the smaller ones, you can get a kit that's got, I think it's 25 bucks. You get the breadboard, you get all this stuff. And the very first lesson is to just get the LED on the board itself to flash. So you don't even really have to hook anything up to it to verify that your USB connection is working, and you have the IDE installed properly on your host. I mean, in fact, I think it's actually in the IDE. It's actually a sample program, and you just have to tell it. Like most of the smaller Unos have it on pin 13 or something like that. But I mean, you could literally just read the instructions and get your first thing working probably in 30 minutes, and then go from there.
Yeah, Ryan, the stuff that you do with your son on the with the robotics thing, I don't think you'll have any trouble with this.
Right. Your kid will figure it out.
Yeah, exactly.
The things to remember is whatever I tell people is be sure not to put too much voltage. If it's a 3-volt chip, you don't put 5 volts on it.
Yeah.
And then the other thing is with the LEDs, to be sure to put like a little resistor in series, a current limiting resistor. Most of the time you'll notice like these things get really hot, but otherwise, it's difficult to damage one of these things if you observe those two rules, and heck of a lot of fun to play with.
And the good thing is it's not a $3,000, 68,000 processor, right? So
right.
I mean, that's the thing. These things are just, I'm amazed how inexpensive they are. I mean, that's like I said, for 40, 50 bucks, you get multiple boards, put them in different parts of your house, and have all the data going to aggregated to a central location. So yeah, they're really inexpensive. And
yeah, I picked up a stack of Arduino Nanos for like, I don't know, 5 for $12 or something like that. So
guys, I have a question.
If you blow one of those up, you just wasted $2, I guess.
Yeah.
Does anybody have experience like turning these devices into commercial devices or like consumer devices?
I don't. This is all really prototyping. So yeah, it's to jump from proto to production. No, I haven't. And maybe, I don't know, any of you guys do with the
Well, you
I-
can.
I know they sell the parts separately. I mean, these are just surface mounted to boards and set up to go, right? So they do sell the parts that you can put on your own circuit board.
Yeah, like the CPU used on the Uno, the original one, it was a, I don't know, I want to say a 20 or 24 pin narrow inline dip chip. Very easy to make your own circuit board if you wanted to do that. Plus, a lot of the Arduinos themselves, they accept what are called shields. So maybe you could base a product on a Uno or something and design your own shield, and the shield just plugs on top of it.
I haven't done anything commercially on it, but there's another interesting thing about the 8266. Most of them, and I'm not sure if the D1 Mini does or not, I have to take a look at it. I think it may. You'll find that the actual Wi-Fi chip has a metal cover on it, and there's an FCC certification. Because this is a radio transmitter, a transceiver, that falls under specific regulations from the Federal Communications Commission. But these manufacturers have gone through and done that testing and gotten the certification. So you can take one of those devices and plug them into one of your own things that that's not a radio and be legal. So that's a big plus right there.
That's a good point. Yep.
Yeah, the upside of the ESP chips is, I mean, to get an Arduino board configured with all the hardware capability that one of those ESPs have, you'd have to add an Ethernet shield, you'd have to add a Wi-Fi shield. It would get out of control pretty quickly. The downside to the ESP is all that code and the hardware itself, it all comes from China. So good luck on getting a security clearance if you're planning on putting it into any sort of government job, if you know what I mean.
Uh-huh. Hey, Rob, when you get a chance, could you throw that link to that kit on Amazon into the chat?
Yeah, I'll do that right now, actually, because I'm on that page.
I've been looking, and I don't find that was a sweet deal. I mean, I don't know if they still have them, but I like having the display. That's pretty cool.
Yeah, and you can buy, I think, 4 of the displays for like $12.
Jeez.
Yeah, it's like I said, it's pretty amazing what you can do cost-wise with these things.
Mm-hmm.
Let's see.
Yeah, I think I see a garage door open detector in my future.
Okay. Well, that sump pump thing is kind of an interesting little application. And like I said, once you get the basics done, then it's all just post-processing of the data to give you something meaningful.
Mm-hmm.
Actually, as we're talking now, I'm kind of having a go at it with the OTA stuff.
Good grief, $13.99. It's insane.
I know.
Well, you definitely want to go and search like an Alibaba or something like that and just see all the different modules that you have for them. The ultrasonic detector, the PIR, the battery packs, the extension boards. It's pretty cool stuff. Most of them you can get from Amazon without too much of a surcharge, but you put together a pretty nice system.
I'm gonna actually, let me switch. I'm gonna share my IDE screen here because I think I reset my Arduino and it may work here. I'm not gonna promise, but let's have a go at it for the over-the-air programming. So, okay, so basically what I've done is I've cut the flash rate to 500 milliseconds. I turned off I hid the shark, so can you see the blinking?
Yeah.
Okay, so now I'm gonna try to do this again. So I'm gonna recompile this thing. This may take a minute or two. And then I'm going to upload using the Wi-Fi port. So I said I'm really amazed at how slow it is. And again, prior to the Zoom meeting, you know, it was taking a fraction of the time. So is Zoom really a resource hog?
I don't think it normally is, but
Okay.
Well, if you have your background turned on, that's sucking up some.
Yeah, it's just got to virtualize the background, right? If you had green screen, it'd be a little lighter test there.
Okay, so it's done compiling. So now let me go to Tools. I'm going to go to Port, and I'm going to change it to the Wi-Fi port. And then let's try and upload this thing. Okay, so you can kind of see it's still flashing. If the upload's correct, it's going to basically do a reset, and then we should see a faster. Oh, good, it is working now. See the upload in the IDE? Okay. So the LED actually went off because it's being programmed. It's doing a reset now. Okay.
It looks faster.
Yeah, so it's blinking at a little faster rate. Yeah. So that's the over-the-air programming of the device. I don't know why it didn't work before, but that's it. So.
Well, thanks for persevering.
Yeah, I was hoping you guys would keep talking more and figure out some other things too. But yeah, that was. I just restarted the Arduino IDE, and yeah, that worked. So that's all I have. I don't know if you guys have any more questions, or I can put this presentation. I got the PowerPoints. I can put it up. If there's any other links that I might be able to share with you, let me know. But the $13 kit is pretty amazing.
Yeah.
Yeah, if you could add the
I don't know if you guys can see these.
that'd be great.
That's so this is a really tiny Arduino.
Okay.
Not much bigger than a postage stamp. Now this one does not have an onboard USB controller, so you have to use one of these USB to serial jobbies.
Okay.
But that's barely. It's like a postage stamp and a half, and this one's using the quad flat pack. So this actually has more GPIO pins, a couple more GPIO pins sent out to the pins than the Uno does. And I forget which guy that is, but here's another one. This is a Nano knockoff from China.
Okay.
And it's a little bit bigger, but it's got a USB jack right on it. So you can just plug that thing in and do a quick test. And there's an LED on here somewhere that flashes. The only downside to these is they don't use the same USB to serial chip that Arduinos use. So you have to, you may have to go find the driver for that, because the Arduino guys use something called the FTTD chip or something.
FTDI.
Or FTDI, and the Chinese knockoff, they use a different thing. It does exactly the same thing, but you do have to get the driver for it.
Are you talking
installed.
about the serial?
The what?
Are you talking about the serial driver for?
Yeah, the USB. There's a chip on there that handles that USB connector.
Yeah,
and it's not the same one the Arduino guys use. So you have to install that driver into your Arduino IDE before you can program this one.
There's been a lot of counterfeits and things like that. FTDI is considered a really solid manufacturer.
Yep. But it's not. I mean, it's not counterfeit. It's a competitive chip.
counterfeiting a proprietary design. Apparently so, because anyway.
Well, all Arduino stuff is open source.
Yeah, but
All the hardware.
they didn't build the Atmel chips and the things like this. But anyway, the other chip that works really well, some of these boards, and I've got some Nanos that use that too, is the CH340. And those drivers come with Windows, and runs on my Pi as well. So yeah, that's the reason. Prolific are very problematic. Prolific is another company that manufactures these, and there's been issues with those. So the FTDI and the CH340s are good choices.
Yeah, I think that's what these guys have on them, that alternate one. That I've never had any issue with it. So
neither did I. Yeah, but
you just have to get the right driver loaded in your environment.
That's the one little hiccup I had when I installed the Arduino IDE on my Mac, was that I had to install that serial driver. When I installed it on the Pi, it was already there. I didn't have to install it. So, yeah. Yeah,
because, yep. So the one last bit of news about Arduinos is the Arduino IDE. I saw a write-up about how the generation 2 of the IDE, they're just going to throw in the towel, and they're going to create an Eclipse plugin for Arduinos.
Oh, okay.
Because it's taken a lot of heat. If you use the editor in that Arduino, in the legacy one, you get you realize there's no features to it whatsoever. And I've actually taken to writing some of the Arduino code somewhere else and just cut and pasted it in there. So
that's a good point, because compared to some other code editors I've used in the past, it's pretty archaic.
Yeah, but again, like for Arduinos, you're going to get like a whole 8K of program space to fill up. So there's not going to be that much code on a real Arduino. Now those ESPs, I think they have a lot more space, right?
Well, it's the program space is 4 meg.
Yeah, a lot more space.
So do they provide any command line tools, so you can just use any editor and just like compile?
There are in the Linux world at least command line tools where you can talk to your Arduino, and you can compile a source listing, and then there's separate tools where you can upload your sketch to an Arduino without going into the IDE, and you can there's an equivalent to the serial monitor. So you can pretty much live, if you have those command line tools in the Linux world, you can get by. You don't ever have to start the IDE. And I actually thought about using those to plug them into the Genie IDE, because the Genie is real easy to add stuff to.
Mm-hmm.
And but I never got around to doing that. So
you can use VS Code also, though it's kind of a pain in the ass to set up.
Visual Studio on a Linux box?
Visual Studio Code.
Yeah, Visual Studio Code, yeah.
Yeah, we use that on Linux.
Yeah, I don't know if it's still that way, but they were saying it's kind of crippled. Things are not all the things are there or something.
I prefer using IntelliJ, and I wish that's where the
good editors.
IDE was. They built it off of the open source version and the community version of IntelliJ. So
I was just thinking the same thing. Eclipse? Why don't we do IntelliJ?
Yeah, exactly.
Well, that was just something I read. I didn't actually go chase it down. They said you can go try it now. You can try the beta version of it. It's like,
They also have a web-based IDE too, I think, don't they? I haven't tried it.
I haven't heard of that.
Yeah, I think you can actually program it on the net and then have it download. I guess they're trying to reach out for having a light footprint for people that want to just play with students and things like that. So maybe worth looking into.
Well, I mean, the legacy IDE is good enough for like STEM programs and maker spaces where you're just, getting something done. You're not you're not building a church or something,
Well, again, the amazing thing is that, you can do fairly rapid prototyping with these. There's not certainly expense is minimal, and it's a pretty way to get going quickly off the ground.
Yep, I agree.
Well, cool. Thanks so much, Rob.
Yeah, you're welcome. Hope you enjoyed it. And
New projects.
there are many more to come.